Welcome, future statisticians, to the lesson on binomial distribution. Now, as we talked about in class with the foreign quiz, there must be four things that are true in order for a question to be binomial. Each observation falls into just one of two outcomes, hence binomial, and this gentleman right here on a bicycle. We call these success and failure. There's a fixed number n observations. The n observations are all independent, and the probability of success, which we call p, is the same for each observation. Okay, so first we will walk you through some formulas. Okay, here's the first formula, and again, these are all on your reference sheet. Now, this looks a little confusing, but it's not too bad. I'm going to kind of walk you through it. So the first part is, it says the probability that x equals k is equal to n choose k, is basically what this is. This is how many ways a certain outcome can happen, and it's basically n choose k. We know that as n choose r in our calculator, but it's the same thing. Now, p is the probability of success, and k is the number of successes. 1 minus p is basically the probability of failure, and n minus k is the number of failures. Okay, and I will show you how to use that formula and plug it in your calculator. All right, next we have mean and standard deviation. They're very easy, much easier than the last chapter. So you've got the mean or expected value mu sub x is simply n times p. It's the number of trials times the probability of success. And then the standard deviation is just the square root of np times 1 minus p. Okay, so here is our example. It says each child born to a particular set of parents has a probability of 0.25 of having blood type O. If these parents have 5 children, answer the following questions. So the first thing is we get used to identifying the binomial parameters. N is the total number of trials, and P is the probability of success. So in this case, since the parents are having 5 children, then there are 5 total trials, and the probability of success in this case is the probability of having type O blood, or blood type O, and is 0.25. So we will be using those numbers to kind of plug into our formulas. All right, so we will create a probability distribution table. Now, this is not something that you will need to do every single time, but I feel that it helps us kind of relate it to the last chapter. So x equals the number of children with O blood type, basically. So you could have 0 kids, 1 kid, 2 kids, 3 kids, 4 kids, or all 5 kids could have blood type O. Now, to show you how the formula works, we're gonna do the first 3 of these, and then we're just gonna type them in my calculator. So the first one, and this is any given number in the probability distribution. So for example, the probability that x equals 0. Now, I'm going to use this formula right here. N choose k, p to the k, 1 minus p to the n minus k. And I'll show you how easy the formula is. So the first thing is, it's n choose k. So out of 5, 0 have type O blood. Now, p in this case is 0.25. That's the probability of success. So, probability of success is 0.25. Now, 0 of the kids have type O blood, so the number of successes is 0. 1 minus p is 0.75. If 25% have type O, then 75% don't. And again, this n minus k here, right? So again, I'm just walking through this formula, is 5, because all 5 must have non-type O blood. So I type that into my calculator. Excuse me. So here's how I type this into my calculator. And I'll do the TI. The Casio version is just slightly differently in where you find the and choose R. So you type the total in first. I'm going to hit math. Then I'm going to go over to PRB, probability, down to NCR. Okay, remember we talked about that in class. 0 times 0.25 to the 0 times 0.75 to the 5. And I get my probability. So the probability that nobody in this family, or none of the children in this family, have type O blood is 0.2373. 0.2373. Okay, now the probability that X equals 1. All right, one of the children has type O blood. So out of 5, how many different ways can I select one child? The probability of success is 0.25, and there's one of those. The probability of failure is 0.75, and 5 minus 1 means that 4 must not have type O blood. So I typed that in my calculator. Now, I like to use the second enter trick, and then I just go back and change these numbers. 1.25 to the first, 0.75 to the fourth, hit enter, and there I have the next one, 0.3955. So that's the probability that one child has type O blood, 0.3955. 3955, 0.2373, 0.3955. Okay, I'll do one more, just again to kind of show you how you write it out, and then we'll just type the rest into our calculator. So probability that X equals 2. Out of 5, I'm choosing 2 that have type O. How many different ways can that happen? Probability of success is 0.25 to the second. There are 2 successes. And 0.75 to the third. So again, 5 minus 2 would be 3 left over. Notice that the 2 exponents always add up to the total n. These 2 exponents here. Okay? And I'm going to type this into my calculator. And again, I'm going to use the second enter trick. And I'm going to go up, and I'm going to change this to 2. And 0.25 to the second. And 0.75 to the, we said third. Hit enter, and there's the probability of having 2 children with type O blood, 0.2637. Again, that was 0.2637. 0.2637. Okay, and the last ones I'm just going to type right in the calculator. So by now you should have a little bit of idea what's going on. So 3 out of 5, 0.25 to the third. If 3 have type O, that means 2 do not. Hit enter, 0.0879. 0.0879. Okay, 4 out of the 5. So I'm choosing 4 out of 5. That means 0.25 to the fourth and 0.75 to the first. 4 type O's, 1 not. 0.0146. 0.0146. And lastly, number 5, or not number 5, but picking or 5 children having type O. 5. That means 5 successes, 0.25 to the fifth, and that means 0 failures, and I get 9.765 times 10 to the negative fourth, which we are going to round to 0.0010. Okay, now again, you're not going to have to create this probability distribution table every single time. I'm just doing that to show you how this relates to the last one. So we get to number 3. Number 3 is, what's the probability that X equals 2? Now, I have that number already, but again, I will walk you through how to calculate it if you didn't want to do the whole table. So the probability that x equals 2 is out of 5, how many different ways can I choose 2, times the probability of success to the number of successes times the probability of failure to the number of failures, and I would get, as we showed before, 2, 6, 3, 7. Okay, what's the probability that x is greater than or equal to 1? Again, as a sentence, that says, what is the probability that at least one has type O? At least one. Now, that's a recurring idea that we talked about in the last chapter. At least one is the probability, is 1 minus none. So 1 minus the probability of 0. Well, if I go up here, I see that the probability of 0 type O blood is 0.2373. So this is going to be 1 minus 0.2373, which I get 0.7627. Okay, that's the hard part. Now the easy part, find the mean and standard deviation. Mu sub x, again, equals n times p. Well, there are 5 total children, and the probability of success is 0.25. Type that in my calculator, and I get 1.25. Standard deviation of x is the square root of np 1 minus p. So that's the square root of 5 times 0.25 times 0.75, and I get 0.9682. Okay, so there is pretty much binomial distribution in a nutshell, and that's it.